Hi, this is Pat Long. Welcome to the second video in our series on the base SAS certification exam. This video is the most extensive. It's covering the managed data section. So let's jump right in. So first off, in the managed data section, we're going to be talking about sorting observations in a SAS dataset. To do this, we're going to use the sort procedure to reorder observations either in place, or typically we usually output them to a new dataset using the out equals option. Also going to talk about removing duplicate observations within the sort procedure. So let's jump back into the code. So first off, we're going to look at the sort procedure. And again, as with the examples in the previous video, I'm going to be looking at the SAS help library. And I'm going to be looking at the cars dataset. Again, the reason I use the SAS help library is so that it's totally reproducible for someone else to use to go through these examples. And I'm going to I'm making an out dataset in my work library because I can't write to the SAS help library. It's read only. So I'm going to call that cars by price, and I'm going to sort by the MSRP. So now let's run this PROC sort. And looking at the output data, we've got the default PROC sort settings going from cheapest, and we can skip all the way to most expensive. The cheapest was a Kia, and the most expensive in that data set is a Porsche. So yeah, so we're going to do some more things with the sort procedure. First, let's look at, so we saw the default going from low to high, but if we wanted to do the opposite of that, we could do, why don't I just copy and paste this? We could just add in to the by statement the descending option. And it would go right there. And this would put it in the opposite order. So the Porsche should be the first, should be at the top of our data set, the first observation, and which it is. So, and then the Kia we looked at that was the first observation will be at the end. I'm actually going to call that something else for reproducibility purposes. So we got both of those data sets in our work library. Just running them again. And so this is just a basic example of sorting procedure by one variable, in this case MSRP. In the next bullet in the exam content guide, they say to remove duplicate observations with the sort procedure. And the easiest way to do this is with the no dupe option. So first you need a data set that has duplicate observations. So why don't we, knowing some of the things we can do with a set statement, why don't we make a data set called duplicate that has cars by price appended on itself. So instead of a data set with, I believe, 428 observations, should be a data set now with, you know, a duplicate for each one. So it should be 856. I think that's the observation count. We'll see in a second. So yeah, so we have a duplicate data set that I've called duplicate. It's in our so yeah, we have a duplicate data set that I've called duplicate. It's in our work library, and now let's use the sort procedure to get rid of any duplicate observations. To do this, I'm just gonna use duplicate and the no dupe option, and then I'm going to make an out data set because I generally do. I think it's a good practice, even if, you know, this is a work library data set. It has a bit more meaning that the duplicate contains duplicates and deduped doesn't contain duplicates. So I'm going to do this by make model, and I'm also going to sort by MSRP. That's assuming there's a unique make and model for each car. You know, there are multiple Kias, for example, in the data set, but there aren't multiple models of particular Kias. So now we're back to 428, which is where we want to be, and the sort is accurate as the model, and you can see this clearly in the Audi section, how the model is alphabetized, and then they're also sorted by MSRP, but unless they're exactly the same, that won't do much. Okay, so that's about all you need to know for removing duplicate observations. Fairly straightforward. We'll continue to use PROC sort in the rest of this video and in subsequent videos for the specialist base programming examination preparation videos. But next, let's look at conditionally executing SAS statements. So now we're going to be talking about conditionally executing SAS statements. We'll use if then else statements to process data conditionally, and use do and end statements to execute multiple statements conditionally. To start off with, let's look at using an if then else statement to process data conditionally. What we mean by this is it could be something as simple as adding an extra column based on a condition in a data set. I'll show you what that could be in a simple example using one of the data sets we just created. So let's make another work library data set called cars if then, and it's going to come from the cars by price high work library data set that we just made. So here's the first if statement. So I'm going to say if origin, and there's a column in the SAS help cars data set called origin. I'm going to say if origin in, I think it's uppercase, sorry, Asia, and we'll soon find out in the log if I'm wrong, and this should have been lowercase. I think it's the first letter is uppercase. Again, it's easy to know if you've done something wrong with the log. And so then, so I've started an if then do statement, and inside this, I'm going to create the import column to be yes in the case that it's of origin in Asia or Europe. Then I'm going to do a coverall, else do import equals no. Now I haven't considered that there might be cars from South America or Oceania in this data set. I don't think there is, but based on the logic I've used, if there is, I'm actually making them not an import, which is probably not great. I could have done an extra else if, or I could have just used an else if origin equals America, then do import equals no, and that probably would have been a better solution. But I think I also wanted to show you the int operator in this example. So let's go ahead and run it and see what happens. So great, we have our original data set, and now we have the import column, which is yes for some and no for others. Let's look at these two. So we can see that Mercedes-Benz is classified as an import and Chevrolet as not, which is right. So now let's use do and end statements to execute multiple statements conditionally. So here I'm going back to the baseball dataset, the SAS help baseball dataset. So I'm actually only going to use one column in this data set. Yeah, let's use, and this is using the, so this is using the keep equals data set option that we discussed in the previous video. And so here's my do loop. I'm going to say I equals 1 to 5. length equals the length, and this is a SAS function that I'm just using, the length of the team name times, do that, times I. And then I'm going to have to put an output statement so that it gets, so that we write this observation to the SAS dataset. And then end. And a run statement. Actually, I'm going to drop the I as well. And let's run this and take a look at what we have. So we end up having let's look at the logs to go through what happens. So we only read in 322 observations, but as we looped through 5 times, we ended up having 5 times that amount. And you see for each length here, the length of Cleveland is 9, then 18, then 27. So it's a very simple calculation, if you recall. It's not very useful in this particular example. It's a little bit silly, but I thought it was a very easy illustrative example to show what you can do with the do loop. There's also various options, so it could do I equals 1 to 10 by 2, in which case we get the same number of output data, but this would be 18 and then 36 and so on. So yeah, that's a simple example of how you can use a do and end statement to execute multiple statements conditionally. So in the next session we'll be using assignment statements in the data step and creating new variables and assigning a value. So now we're going to be talking about using assignment statements in the data step. We're going to create new variables and assign a value, assign a new value to an existing variable, assign the value of an expression to a variable, and assign a constant date value to a variable. So in this video we're going to be using the iris dataset again, and we're going to first off create a new variable and assign a value to that variable. So I'm going to call this dataset Versicolor. Spell that. And this is from sashelp.iris. And I'm going to use the where equals dataset option, and just say if species equals Versicolor. And I'm going to make a new column. It's a new column to my work library dataset. I'm going to call it petal area, which will simply be petal length times petal width. And so let's run that. and verify we did what we thought we did. So I could have done this with all of the iris species, but I just did it with Versicolor. And this is my new work library dataset called Versicolor. And you can see that I have a new column called petal area, which is simply petal length times petal width. That's pretty straightforward. So next, let's look at assigning a new value to an existing variable. And let's just keep on using the same data set that I just made. It's called Versicolor. Set Versicolor. And say we wanted to view this in centimeters. Instead of millimeters, let's change petal area to equal petal area that we just made divided by 10. And now you'll see petal area is petal length times petal width divided by 10. Probably won't want it in different units to the other stuff, so it's not a great example. But yeah, so we've done the task of assigning a new value to an existing variable. So let's look at assigning the value of an expression to a variable. So again, I'm going to keep on using the same data set, Versicolor in my work library that comes from sashelp.iris. Let's keep on using the same column that we just have been messing around with, that we created. So let's make a new column called size equals large, and that's our default. We've initialized this column called size, and it's or variable. We've initialized this variable called size, and it will be large unless we say otherwise. I'm just going to use one if then statement. So I'm going to say if petal area is less than 48, then size equals small. And a semicolon. And let's run that. And see what the new variable looks like called size. So yeah, it's large unless it's below 48. So yeah, it's looking good. We have a small. This row is has a small observation. There's a few others in there, and yeah, looks like we did what we wanted to. Log looks good. Again, if anything does go wrong, it'll jump out to us in the log, hopefully. So now let's move on to the next one, which is assigning a constant date value to a variable. Okay, let's just add another column onto VersaColor. I think the easiest way to do this is to just use the today function. Let's pretend, the column could be the date we updated this data set. I'm also going to format it so we can see it nicely instead of just the number. Let's use this mun_yy5 format, and we're creating a column called date updated, and it is just equal to whatever the today function returns. And just wait for that to run. Didn't seem like there was an error or anything. That's always good. And yeah, well, I didn't put a day in there, even though I put because I just used the or the mun_yy5 format. So I just have July 20 or June 20 in that format. But there's a number behind it, if we wanted to see that too. And you can play around with that. Again, this full code's available on my GitHub page and in the description of this video below. So next, we'll be moving on to modifying variable attributes using options and statements in the data step. Now let's look at modifying variable attributes using options and statements in the data step. We can change the names of variables by using the rename equals dataset option. We're going to look at using label and format statements to modify attributes in a data step, and we're going to define the length of a variable using the length statement. So in this video, we're going to be looking at modifying variable attributes using the options and statements, using options and statements in the data step. First off, let's look at changing the names of a variable using the rename equals dataset option. So I'm just going to go back to the VersaColor work library dataset we just created, and this is derived from the SAS help.iris dataset. Rename equals. Let's change the name of the size column that we variable that we created and call it leaf size. And the log should let us know if we've done anything wrong. So that looks good. And yeah, we changed, if you recall, when we were looking at the previous section, we created a column called size. And now that's called leaf size. Okay. So next, we're going to use the label and format statements to modify attributes in a data step. So let's go back to using the baseball data set from the SAS help library. And let's only keep a few of the columns. Let's make it name, NRBI, what else do I know? NHome and salary. So yeah, we'll just take 4 columns from the data set. So and let's use the label. Let's use the label statement to change salary. We're giving it a label. I think it actually already has one in the SAS help library. You'd have to PROC contents to check me on that. But let's give it a new label called salary and thousands of US dollars. Okay, and semicolon. So that's our new label for it. Whether or not I already have one, we're overriding it. If it did, I think it probably did. But I have to check that with PROC contents. Anyway, so, and let's give it format salary to be a monetary one. We'll make it 10.2. And so there you can see we've just formatted that variable salary, and we've also given it a label. And let's just make sure we don't have any errors in the log. That looked good. And then the output data set. Oh, didn't need to do that. In the output data set, there are some missing values in this. I remember that now. This is the salary and thousands of US dollars. So it seems quite low, but I think it's data from 1986, so it's quite a long time ago. So that's about it. That's a basic example of using label and format statements to modify attributes in a data set. So now let's look at changing the length of a variable using the length statement. Let's just go ahead and use that baseball data set that we just made in the work library. And let's make a variable called short name, and let's just make it 4 characters long, and we'll just set short name equal to name, but it's going to chop it off at 4 characters. So let's look at what that looks like. So that seems a bit silly, but there basically I've just taken the first 4 characters of the string name and put them in a column called short name. And so yeah, this is how you might want to. Well, again, it's not a especially useful example, or maybe it is, depending on what the in a different data set it might be quite useful. But this is just a simple example of how you might use the length of a variable, how you might set the length of a variable with the length statement. So yeah, that's about it for modifying variable attributes using options and statements in the data set. In the next video, we're going to look at how we might accumulate subtotals and totals using data step statements. Now we're going to look at accumulating subtotals and totals using the data step statements. we're going to use the by statement to aggregate by subgroups. We're going to introduce the use of the first dot and last dot processing to identify where groups can begin and end. And we're also going to look at the retain and sum statements. Totals and totals using the data step statement. Using data step statements, using the by statement to aggregate by subgroups, and using the first and last processing to identify where groups begin and where they end, and using the retain and sum statements. So first off, I'm going to just do a report of the data set I'm going to use. And that's going to be SAS help.cars. So. And I'm going to create an out data set called let's call it cars inventory. And here's the key part for what we're doing is that we need to sort it by let's go make a model like we have before, and we'll run that. Well, we'll run that when we run our data step. So let's use the out data set that will be in our work library. And we'll just keep a few columns. So P and invoice. And so here we're using the by statement within the data set, and we have to use what we just sorted it by. Sometimes you might be lucky and the data set is already sorted conveniently for the by statement, but in general I think it's best practice to just use the sort procedure to make sure it's sorted the way you want it. So here we're going to jump into using the if first dot. So we'll do if first, let's do if first dot make, then model ID, let's call it model ID equals 0. So we start counting from 0. So this is, we're using the first dot, and then I'm going to show you the sum statement and the retain statement within this data step too. So model ID plus 1, and this is let me type that in there, an example of the sum statement. There's a sum function too in SAS, which is, probably more, well, the sum statement is very commonly used, but obviously they're quite different. And let's use a retain statement here. And that's for model ID. And let's just put that in there, although that's a bit more obvious. Retain statement. And let's run this. Hopefully I don't have any syntax errors because I'm going to run the sort procedure and the data step we just went through. And then we'll look at the output, assuming there's no errors. I did see a warning there. Okay, yeah. Actually, in the next session, we'll get onto why this is a very useful thing. SAS has assumed that I mistyped that, and it's interpreted that as then, which it should be, which is great. So we don't really have a problem. Let me fix that. So when I save this and put it on GitHub, there's no mistakes in it. So yeah, here's our output data set. And you can see I have a model ID. So I have a model ID for each model within a make. So you know, if it's the first BMW, it starts at 1. And then when we go on to the next, car make, Buick, should again start at 1, and we have an ID for each different model, and we must be at another 1. So this is where you really get why this is useful, the first dot, how you might use it. So we've kind of covered using the by statement with the by, make, and model, using first dot processing to identify where groups begin. And we've also used the retain and sum statements, but we haven't looked at what the last, what last dot might do for us. So let's, we'll do a second example so we can look at what we might use last dot processing for. Okay, so I'm just going to copy what we just did with the first dot processing and make a last dot processing example, very similar. Let's call this cars inventory 2. I'm just going to put a note in there. And let's sort it by make and MSRP instead of make and model. Make MSRP, and this is called cars inventory 2. Cars inventory 2. And so let's go last dot make. So if last dot make, then most expensive equals no. Oh, sorry. Yeah. So that's going to be yes, but let's establish that variable as most expensive equals no. And then if last dot make, given the sort, this will be yes, hopefully. We can't use a sum statement here because it's a string. We'll keep on using the retain statement. And yeah, this should run and you should see what it does exactly. So we'll check the log, make sure nothing went wrong. Looks like it went fine. And so yeah, let's keep an eye on the Acura, sorted from highest to lowest. This is the most expensive one, perfect. Then we're in Audi, I think, and this is the most expensive model, and so on and so on. Yeah, so I think we've about covered it in those two examples. So what we just went through was using the by statement to aggregate by subgroups, using first dot and last dot processing to identify where groups begin and end, and we also use the retain and sum statements. So next we'll look at using some SAS functions to manipulate character data, numeric data, and SAS data values. Now we're going to look at using SAS functions to manipulate character data, numeric data, and SAS date values. We're going to go through a lot in this section, and we're going to look at using SAS functions such as scan, substr, trim, upcase, and lowcase to perform some common tasks like replacing the contents of a character value, trimming trailing blanks, searching a character value, and extracting a part of that value, and converting a character value to upper or lowercase. To manipulate character data, numeric data, and SAS date values. First off, we're going to use SAS function scan, and then we'll use substr, trim, upcase, and lowcase to perform these four tasks here. So let's use the baseball dataset. I'm going to make a new work library dataset called baseball from SAS help .baseball. I'm also not going to. I'm not going to keep every. I'm not going to keep every variable. So I'm just going to do a keep equals name, team, years in the majors. And so from the name variable, I'm going to create a new variable called first name. I'm going to use the scan function. First argument is the variable we're deriving it from, which is name, and then the second argument in this case it's going to be -1. So this is the very last part of the string, and the length of the string it's the very end of the string. So that's the second argument we're going to use, and then the other one is a delimiter, and you'll see this more clearly because we're also going to make another one called last name equals scan name. Second argument here is 1, +1, which means it's the first part of the name variable, whatever that variable may be in a particular row. And then the delimiter for this one is going to be comma, and you can see what this is doing more clearly once we run it. So let's run this. No warnings, no errors. So let's look at Allenson Andy as the name, and you'll notice here there's a space between the comma and the A. So that was our delimiter with the first name. So we went all the way from the last part of this string -1, the second argument in the function, and then with the delimiter in the third part, we use this space. So we have Andy just the way we want it, and then a little bit more straightforward with the last name. We're just going from the first observation to the comma, and that should hold true with all of these players. So yeah, that's about it for getting started with the scan function. Now let's look at some of these other functions. I'm just going to carry on using this same work library data set I've already made. And so here we're going to use the substring function, the uppercase function and the lowercase function, just to give you an idea of what those look like. So here for the substring function, so the first argument, just like the scan, is you know, the variable that already exists, team. And here the position. Here, just like in the scan function, we're going from the first character in this string. And then the second function is the last position. So for, that's not going to work. There should be an underscore. I mean, it doesn't matter, but you can't have a hyphen in there, is why I'm taking that out. So anyway, I digressed a bit there, but this is going to be a 3-character string, which is just the first 3 characters of the team. And then I'm going to look at the uppercase function, which is simply turning a string, whatever way it looks before, into all uppercase. So it's just going. I'm just going to do uppercase team, and then let's make team lower as well, because at least in this string, the first letter is actually uppercase, and the rest are lowercase, I believe. So yeah. So fairly straightforward with those two and with the substring function. Okay, and so here we see the team where it's you can get this, and it's not covered in the exam, but you can get any string to be of this form using the PROC case function in SAS. It's not part of this exam, so I won't really talk about it. So here you can see the whole thing is uppercase, and here you can see the whole name is lowercase, and here you can see I developed a team code variable that's the first 3 characters of the string. So yeah, that's about it for those 3 functions. Oops. And so now let's look at using the trim function, and we'll have to kind of set up an example to illustrate how you might use that. We'll keep on using the same work library dataset called baseball. Let's call this variable team trailing blanks. It's a long variable name, but it illustrates what we're talking about. I'm also going to use the cat function here. This isn't, I'm just using this for demonstration purposes. It's not on the, it's not covered in the this base SAS exam. And here I'm going to create another variable called team no white space. And we'll get rid of the trailing blanks from this column. Making sure I spelled it right. So again, we should see this nicely in the output. What exactly the trim function called that? This is the trim function. Removes trailing blanks from a character string is how it's described. So yeah, let's look at what this does and what exactly I did with this team trailing blanks variable here. So yeah, team trailing blanks has all this white space on the end. And it's a bit of a silly example, but team no white space doesn't. We could also likely take care of this problem, with the length statement that we talked about earlier, a couple of sections ago. But yeah, I think that's about it for a basic example with the trim function. Now let's move on to looking at put function. So here I did select a column in the beginning, at the start of this section, called year major, which is years in the major league. And sometimes, this isn't a particularly good example of a case where you might want to do this, but in some scenarios you might want to change a numerical variable to a character. Maybe there's a good reason for that. Maybe you want to put a 0 in front, and if you make it a number, that's going to get chopped off. Or maybe there's a good reason for it, but here's just a very simple example. We're going to take the years in the major column, and using the put function, you can just easily make that character rather than a numerical variable. So let's pay attention to what it says in the log. And then yeah, here's our character version of year major. You can see it's left indented, or in SAS Studio, you can see whether it's a character variable, or in the case of the original year major, it's a numeric variable. So yeah, that's about it for a very simple, basic example of using the put function in SAS. So now let's move on to using some numeric functions in SAS. We'll keep on going with the same baseball data set that we've been using. Actually, I'm going to use a different data set to baseball. I'm going to use one I haven't used so far in this video. It's called appliance, and it's another SAS help library data set, and I think you'll see based on the structure of this data set why I'm using it for this example. So yeah, first off, we're going to look at the sum function. And this data set is very conveniently named, that's why I'm using it. And so let's look at this. I'm going to run this sum function, and we'll look at the results. And also I'll show you what the appliance data set looks like. Oh, I didn't put the set statement, sorry. So that's an obvious mistake. Let's run that again. Okay, so you see it goes from units 1 through 24. I believe it's appliance sales by a store, and here I summed up those for each row, so you can see how useful that might be. A little trick I used in there was of units 1 through 24. I could have just, if I'd only wanted to see units, if I only want the sum of units 1, units 2, and units 3, I would have done this. And let's look at what that does. There are also missing values in this, and I'll get to mentioning that. There was a note in the log about that. So you can see now it's a much smaller number. It's just the sum of units 1, 2, and 3. So 16 we can see in row 1, and 16 is what we get in the sum. So just wanted to explain that. But we have this convenient syntax that we can use for of units 1 through units 24, and we're going to do a similar thing for the main. One of the limitations is that there are missing values in this data set, and in the main, if there's only one of these 24 values, you'll just get your mean will be the same as that one particular observation. But maybe you want that. It depends on what you want. And I'm also so this is the mean function here, and I'm also going to look at the round function. But to make that more clear, I'm going to, if I can type, make sure I have a decimal. So I'm going to make a new column. This isn't anything. This is what we're going to round, and I'm going to make sure it's a decimal. And now we'll round that. Let's call that appliance sum round. Yeah. And so this is the round function. And there are more arguments it can take depending on how you want to round. But this is just a basic example, and using the default parameters. So yeah, let's see if this works, and I haven't put any syntax errors in there. Looks like it's good. So here's our outputted data set. in the work library. So here we have the main function, that's calculation, and then the sum. Oh, sorry, this is the sum decimal where I intentionally made it a decimal, and this is the rounded number of this. And given that I multiplied this column, the appliance sum, by 0.999, these should all equal the appliance sum column. Let me see if I can find what I was talking about with the missing values, with the mean. So yeah, there's a lot of missing values towards the end of this data set. And you'll see here the sum and the appliance mean are equal because there's all missing values except for one unit. So, you know, in general, and I don't recall this happening on the base SAS exam. I don't remember seeing a data set with missing values to worry about. But maybe, you know, that's likely what you want, unless you're going to be changing the missing values. And I don't think you won't need to do that on the base SAS exam. So you know, the main function will work great for you. So now let's look at yeah, we haven't covered a couple of these. Let's look at the largest and smallest functions. And we'll keep using the same data set we just used. And so we'll introduce largest, well, I'm going to call largest 1. And its first argument is going to be, in this case, it's going to be 1, and you'll see why in a second. Let me just copy this. So, okay, and largest 1 returns 33. 32 for the second row. So, so it's just returning one value is the largest of the numbers. You see units 10 is where these two occur. And so that's basically all there is. If the argument is 1, it returns that 1. Let's copy this. And we'll call this 5, and we'll return, and we'll put 5 as the first argument to this function. Then we'll look at what we get. Okay, so so we get 7, and so it's returning the 5th largest observation across that row. And so you may be wondering why that might be useful, but it may if for some reason you want to you definitely wanted, if you wanted to see the top 3 or 4, or you wanted to see the 5th largest, you can see how that might be useful. It does perhaps seem a little bit odd. And then we'll do exactly the same thing with the smallest function, and you've guessed it, it does exactly the same. The arguments, I'm going to change the name of this so I don't cause any confusion, to smallest, and this is the smallest function, and that will return the smallest single value. And I'll call this smallest again so we're not confused. Yeah, and it's going to do exactly the same, but in reverse. So here we, not much going on with this particular row. The 5th smallest is the same as the smallest, but you can see there's this difference in certain rows. This is the 5th smallest. Yeah, so that's about it for the smallest and largest functions. They're quite useful, especially with a data set like the appliance data set. Yeah, they're listed in the study guide, the rand function and the int function. The int function does the same as the round function, but it truncates the value, so it doesn't necessarily round to the nearest number the way the round function does. So it just gives you the closest. It truncates and gives you the nearest integer. And the rand function gives you so if I took the rand and you have to give it a distribution. If I took the normal distribution, if you know what a normally distributed random variable is, then you know what this does. But you can choose any common distribution, and you'll get a random variable based on that distribution. So it's really very minor detail, so I don't really want to go into it too much, but if you do have a background in statistics, you'll have an idea what I'm talking about. I'm just going to make that a column. And you'll see that rand1 column I made. Here we have a normally distributed random variable all the way down as a variable in the data set. It really actually has nothing to do with this particular data set. I could have put it in any data set. But yeah, that's about all I want to say about the rand function. Now we're going to move on to looking at SAS date values and using the MDY, today, date, and time functions. For the next few examples, I'm going to be using the SAS Help Retail data set, and I'm going to make my own work library data set called Retail. I'm going to, there's actually a variable on there called date, and I'm going to preserve that as date original. And there's also columns on this data set called day, month, and year, and I'm going to, using the MDY function, make a new variable called date, from the day, the month, and the year. And let's run this and we'll take a look at what we're doing here. Remember, we're using the MDY function in this example. So as you can see, there's a year, a month, and a day column. And there's a format here that's in place. So I think going forward, it's going to be best just to drop the date, the original date and the data set, and then we'll have the we'll just have the numerical representation of the SAS date. So that's more convenient. All right, so let's move on to the next example where I'm going to do something similar. I'm going to drop from the work data set we just made. I'm going to drop day, the month, and the year. And I'm going to recreate them using the month, day, and year functions. So now I'm going to say month equals month, date, and so on for the day. And I'm going to use the year function to get the year. That's a bit. So sorry, this should be date inside. So it's a bit silly to do this because I'm just outputting the same stuff that's already in there, but I think it gives a good demonstration of how you might use these functions if they didn't exist. And of course, quarter will give you the same thing. I'm not even going to do it. Quarter will give you the quarter 1, 2, 3, or 4 from the year. And so, you know, I think I made a mistake in here. This should be month. This should have been day. And if I run both of these data steps, I'll make it correct. So yeah, the month is back the way it should be. The days were all 1 to begin with. And we're starting out from 1980. And we have our date column that we made in the first data step. Okay, so now moving on, we'll look at the next four functions, the intck, intnext, dateDiff, and yearDiff functions. So we'll keep on using the same data set. And so just bear with me while I type these out. So this, you'll see what this returns. Let's run this one first, and then we'll talk about it. So I'm going to add some more to this data step, but let's run it and we'll see exactly. Notice I'm using the today function, so this is going to return today's date whenever you run this or when I'm running it. Oh, we have an error. What did I do? What's the log say? Oh, of course, sorry. It needs the third argument, which is the column from the data from this data set. Yep. So again, the log's your friend. It's good to look at what it says, and then you can immediately know what to do to fix it. So here, days before is the difference between January the 1st, 1980, and today's date. You know, when this was run. So it may be different if you run it 2 years from now. But yeah, that's all. You know, again, in this example, I don't know how useful it is, but it can be quite a useful thing. And this doesn't have to be today. This can be another date time object. And so years before, I'm just going to stick in here. It's the same deal. Sorry, years before is a column name I'm given, but I'm going to use the same and then we're going to look at int next. So this, let me run this, and you can see it does, it does the same thing, but in years instead of days. So we're going to get, this was 4 years before 2020, so that makes total sense. And so now let's look at what intnx function does. So along similar lines, so this is returning the date for 40 years from the date here in the data set. So I'm adding 40 years on with the int next. Again, in this example, it may not be obvious why that might be useful, but I'm sure you can think of examples where that might be a useful tool to have. And let's look at the final two, the date diff and the year diff. So I'm going to make a variable called date difference equals date diff and so this is going to be the difference from that date column to today, and the third argument you have to give it is this is actual, because I think there's some settings where you can change this parameter to the function based on assuming no leap years, but this is actual taking into account leap days, and you know, similarly, I'm just going to copy this because year difference is very similar. Just change this to year diff, and everything else can stay the same. So and there you see the year difference between today's date and the particular column, in this case the 1st of January 1980, and there's the date difference, which is actually the difference between the years later 40 and the date in the original data set. Okay, so that's about it for this section. Next we're going to be using it, taking a look at using SAS functions to convert character data to numeric and vice versa. Next we're going to look at using SAS functions to manipulate character data, numeric data, and SAS date values. So in this section we're going to go over using SAS numeric functions such as sum, mean, rand, smallest, large, round, and int. We're also going to create SAS date values using time date functions. We're going to extract the month, year, and interval with a variety of SAS functions like year, quarter, month, and day. We're also going to look at performing calculations with date and date time values and time intervals using the 4 functions listed at the bottom of this slide. So now we're going to look at using SAS functions to convert character data to numeric and vice versa. So for this example, to explain the conversion the SAS uses to convert values between data types automatically, let's use the data line statement to make our own data set. Model, and let's let's call this just like the SAS help library data set called cars. I'm going to use 3 of those columns, and I'm also going to make this one character. I think I spelled accurate correctly. I don't remember the MDX. And let's say it has 25. This is probably not exactly the same as what's in the SAS data set. Let's say the Buick Regal has 20, and the GMC Con has 14. Okay. So notice I made this a character variable, and that's mainly going to be for illustrative purposes. Let me just do a PROC contents. Okay. So yeah, I'll just run the contents procedure and the data set at the same time. Okay. So yeah, you see there's the default length is assigned, and they're all character variables. So now let's look at how we might change this in the least elegant way. The MPG highway column from a character to a numeric variable. One quick and dirty way to do it would just be to multiply by 1. So let's call this MPG highway num, and it is equal to MPG highway times 1. And so this is what we're getting at, how the character values have been converted to numeric at places given by. So this is how SAS automatically does it. And notice this is that since I'm doing a multiplication multiplicative operation on it, that it's going to have, want to be a number, and it just gives us a note saying that character values have been converted to numeric. If I was trying to multiply y by 1 or some other string, then it would throw up an error. But yeah, so now let's look at PROC contents for this data set. I called it my cars _1, and we should see a difference. So here I have MPG highway num is a numeric variable. So that's a nice easy way to do it. It's the least elegant and probably not the most advisable, but you can see how SAS can work with that. So now let's talk about using the input function to explicitly convert character data values to numeric values. So here I can make another data set. Let's just copy this. We'll call this mycars2. And yeah, I can just, we'll just go with the same name, MPG highway num. And this will be the best way to do it. Using the input function, we can make it, we can customize it and we can, you know, make it a particular length or format rather than the default that SAS may give to it. So yeah, let's see what that looks like. So here we have MPG highway num, just the same as in the previous example, but note here there's no warnings in the log about automatic conversion. SAS knows what we want to do with the input function. And now let's look at the PROC content on this one, just to see the difference since I use the input function. It's a bit more controlled. You know, I have a bit more control over what I did exactly there. So yeah, so basically it looks the same as the data in mycars1, but there's no note in the log about automatic conversion. So I'm just going to move that to be under this heading. Okay, so now let's talk about using the put function to convert numeric data values to character data values. So here's one thing I can do. Let's make another one. And can use the put function to, let's call this MPG highway string. And we'll use MPG highway num, which we know is a number. And so let's see. Sorry, so this is from mycars. Let's take it from mycars2. So that this column exists. And we're trying to just make character variable here. So we did have a warning in the log. Variable MPG highway num has already been defined as numeric. But in our output data set, this guy should be a string, just like the original one was. Let's check that in the PROC contents. And so yeah, we created a string. Actually, we created a string of length string of length 6. From the MPG highway num column. So this is just the basic use of the put function. And so that's about all we need to know for that. And now let's move on to processing data with do loops and explain how iterative do loops function. So I'm just going to make my own data set for this one rather than using a SAS help library data set. So I'm going to call this one ice cream sales. And I'm going to initialize a variable called sales and set it equal to 0. Then I'm going to start a do loop and say do sales equals 1 to 100 by 2. So let's say I only sell ice creams in pairs. And then my total sales, my total equals sales times 1.5, which is the price. And we have to put the output statement. And then end. And let's run this and look at what we get. No syntax errors. So yeah, here's my point. So as we as we go in twos, we get extra $3 for each sale, and so at 15, we'll get 22.5. One mistake I kind of made on this data set to make it less meaningful was I probably should have started at 1. So we'd be at 2, 4, 6, and so on to 100. But anyway, illustratively, I think the idea of what we're doing here is quite obvious. So yeah, let's now look at using do loops to eliminate redundant code and perform repetitive calculations. I think we just did that essentially, but let's use a conditional do loop too. So let's throw in another variable for this guy. Actually, let's call this a different. Let's call this by a different name. Let's call it ice cream sales. Wow. And let's make a variable called inventory. And let's say we have an inventory limit of 350. Let's do total equals 0. And so here's our do loop. Let's say do while inventory greater than 0. So if we have ice creams left, and we'll do inventory as we go through this loop, it's going to be equal to inventory minus 1. So we lose an ice cream each time we sell one. And then total equals total, which starts out as 0, plus 0.75, which is what we said the price of one ice cream was. And let's see what this is like if I don't have an output statement in there, and then we'll see what it's like with one in there. So it's just a one row, basically a one row data set, and it's just giving you the total. That if you run out of all those ice creams, your total, you have an inventory limit of such and such. I think it was 350. If you're out of all of those, your total will end up being 262.5. But if you want like a lookup table of everything, and this kind of shows what the output statement does, you stick that in there. And now you have the status at every point as you go down. So you're starting off with a lot of inventory, and the output might be useful, not necessarily for that one case where you sell them all. But if you only if you end the day with 259 left, you've earned $68.25. So yeah, that's a good example of a conditional do loop. Okay, let's now look at a nested do loop, and we'll just keep on going with the ice cream example. So I'm calling this one ice cream ID. And so here's my first do loop. Do I equals one through to 7. And so in this example, this is my ice cream ID. So ice cream ID equals I. And then now I'm going to start a loop, and this is a nested loop inside the other loop. So I'm going to call this J equals 1 to 5. And this is my topping ID. So topping ID equals J, and this is where we'll put the output statement. And we'll end that one. And then we have to end the other do loop. So, it doesn't matter for this SAS certification, but I do try and keep the indentation, especially for do loops, consistent, that the do and the end, or the if and the end are indented the same amount of spaces or tabs. I'm also going to drop I and J, so then I output 2 in a drop statement. Okay. And now let's look at what this looks like. Okay, so you just see all the different combinations of ice cream ID. Let's say one is representative of vanilla, and then toppings. One is chocolate chips, two is peanuts, three is M&Ms, and so on. And then here are all the other combinations. So this might be, this is just a basic example of how you might use a nested do loop inside a data set. And that's about it for this part. We'll move on now to looking at restructuring SAS datasets with PROC TRANSPOSE. Now we're going to look at restructuring SAS datasets with the transpose procedure. Using the transpose procedure, we're going to select variables to transpose with the var statement, rename transpose variables with the ID statement, process data within groups using the by statement, and then we're going to explore some other PROC transpose options. Restructuring SAS datasets using the transpose procedure. Before I illustrate some examples, I'm going to look at the data set we're going to be using for these examples, because it's kind of useful to see what data set this might be appropriate for, for transposing. What kind of data set would be a good candidate for the transpose procedure. So let's look at the shoes data set in SAS help library. So you can see it has region, product, subsidiary, the number of stores, and sales. And so this is the one we're going to be using for all the examples on the transpose procedure. We'll get into why it's a good candidate, or you'll see why it's a good candidate as we go through the examples. So let's start off by selecting a variable using the var statement. So let's do PROC transpose and data equals SAS help dot shoes, and here's the var statement, and the var we're going to use is inventory. Okay, and let's run this. And so here's our out data set. I didn't specify a name with an out statement, so it's just made one called work.data1. And here you see the inventory. I also didn't specify what columns to name things. So that's your basic transpose. If you notice, there were several different options, but by limiting it to var, with the var statement to inventory, I only get inventory transposed. So let's move on to the next example, where we rename transpose variables with the ID statement, so we have a bit more meaning to our column names. And so I'm just going to copy this. So to really make use of this, we'll add a PROC sort, so we can actually do the next part, which is processing data within groups using the by statement. So since we're familiar with the sort procedure, so we'll just make a work data set called shoes also. And we're going to do it by which column? Let me open up the, yeah, we'll do it by subsidiary. By subsidiary. Just make sure that runs properly. And it does. So that's going to be our input. And you'll see where I'm going with this with the ID statement. So it gives us meaningful names for our columns. So let's just use this as the basis. And var will still be inventory by, since we saw it as subsidiary. And we're using our work library data set. And so for ID, let me just look up what name that is again. Product is what we're going to want to have. And run. And now we can look at the output once I've run this. So here we are. So here you see, you know, for subsidiary, and so let's run through the code. So our var is inventory by subsidiary, and the ID is product. So, oops, sorry. So here we are. We're by subsidiary. The ID is inventory. And sorry, the var is inventory, and the ID is product, which is where we get the names here. We get meaningful names, unlike in the first example. So you see for Addis Ababa, there's a boot inventory of 191,000. And so you see that for these different IDs. So you can see how this is a very useful example for getting totals by a particular product ID or some such. So yeah, and that really covers also the next example. So I'm going to put that in the one above. So there's that. And now we'll just talk about using, take out that run statement. Now we'll talk about using the transpose options. So yeah, you'll notice that I've been creating work data sets, but we can give them a real name with the out equals option. And using prefix equals or name equals, we can also get more meaningful information. So let's just copy and paste. Let's just insert this here. And these options will go over here. So I'm going to call it out equals shoes t prefix equals group and name equals category. And I'm going to get rid of those options. So here you see we didn't take out the var, so there's 4 rows instead of 1. When we were just doing the inventory, there was just 1. And here you get all these groups that I've just labeled as a prefix. Instead of having column 1, we've got group 1, group 2. So yeah, that's about it for the basics of PROC transpose that you need to know for the base SAS. Now we're looking at using macro variables to simplify program maintenance. This involves creating macro variables using the let statement and then using macro variables within SAS programs, within data steps or outside of data steps. So let's jump back into the code. So back in SAS Studio here, and let's get started with looking at %let. Again, with SAS Studio, you can see that it creates a macro variable and assigns it a value. So I'm going to say let's name equal Pat. And SAS treats all macro variables as a string from the get-go. You can perform numerical operations on them, but this will be a string. I don't have to quote it or anything. And something I like to use, it's not in the exam, but it's useful. The %put lets you see your macro variable in the log, and that's just very useful. This isn't a part of the base SAS exam. I just think it's very useful to know for troubleshooting. And then I'm going to make a second macro variable using %let, and that's going to be the date equals. And then again, sysfunc is used to execute a user-written function. You don't need to know this for the base SAS exam, but it's just a useful thing. So you can ignore this. This is the today function. I think we talked about that earlier. And again, I'm using the %put for so I can print out the date. The date equals &date. Okay. And so let's take a look at what these look like in the log. And so this is where I think the %put is useful. You see name equals Pat, date equals whatever today's date is based on the today function. So some useful stuff there. And so now let's look at using macro variables like this within a SAS program. So let's go back to our, let's just use the transposed shoes T dataset we did in the last section as our input dataset. And let's call this okay, I'm making another macro variable, %let. Let's call it audit ID equals 17. Again, this is just me. You don't have to do this. It's not necessary to know it, but I'm going to use the %put just because I think it's good practice. So I can see this in the log. So there. Now let's use it in a data step. So again, we're using the most recent data set we just created. I'm going to call this shoes T modified, if I can spell that. Going to use the set statement, and it's just a work library data step that was created in the previous section. So if you haven't run that recently, you want to just rerun that snippet of PROC transpose there. And also I'm going to format the date because I'm going to use the date variable I created up here, the date macro variable here, sorry, here in the let statement. Modified date, and you know, you could just print out the date number, but this way it's in a nice format. So modified date, and so I'm instantiating modified date here. It's 2200, and also I'm creating modified by, which I'm making it numerical, so I'm just going to missing value as a period in SAS. So okay, so here we go. If category equals returns, then do. So we've talked about if then else statements earlier, so you should be familiar with that. That's part of the exam. This is just kind of a review of that, so I won't go over how what exactly we're doing with that. And here you'll see I'm going to change the date to today's date that I set above, and the modified by is going to be audit ID. Okay, so and let's close this if do, and finally we'll get to the run statement, and we'll see exactly what we did here. So okay, and oh, make sure you run those macro variables, because I don't think I actually ran them, because otherwise they won't exist and they won't resolve. So. And so let's run this now and then see what happens. And the cool thing here is in SAS Studio there's 395 columns. That's the last ones are the ones we updated, which is modified day and modified by. Remember, I selected if category returns, and then I'll do stuff. So I actually changed group 1. I added 10,000 for it to it, just to do that. And then in the final 2 columns, you'll see it was modified by audit ID number 17, and you know, whatever day today's day is. Yeah, so that's about it for the entire managed data sections. In the next video, we'll be looking at error handling. Remember, all the source code is linked in the video description. I'll go through this, make sure there are no last-minute errors, and link will be posted on my GitHub page and linked in the description below. Okay, thanks for watching.